Now, since that we must be 90%, 90 to 95% thorough with our concepts, let's really test as to how we can apply these concepts. Now, what we are going to have is a few questions which will really test. One, they will test our discernment, whether we'll be able to differentiate between when to use permutation and when to use combination. Or also we have cases where we use a combination as well as permutation. So we're going to take up some uncommon problems next, which will really make our fundamentals clear. And we need to try them out. So keep a paper and pencil. Maybe you could pause the video, work out and check whether the answers are what we have in hand. So let's see what we have in these uncommon problems. Okay. Now we have an interesting case. We have sum of all 4-digit numbers containing the digit 2, 4, 6, 8 without repetition. So obviously you will be having 4 factorial such numbers because there are 1, 2, 3, 4 such digits and they are not going to be repeated. So you can arrange them in 4p4 ways, that is 4 factorial. They have not asked how many such numbers are possible. They have asked the sum of all such numbers. Now, how do we know that these are going to be like this? If you see, say starting, suppose you have a number like 2, 4, 6, 8. You have 2, 4, 6, 8. You also have 2, 4, 8, 6. You may have 2, 6, 4, 8. You will have 2, 6, 8, 4. Then you have 2, 8, 4, 6 and 2, 8, 6, 4. So these are all, there are 6 such numbers, 4-digit numbers starting with 2 and with all these numbers occupying the hundreds place, tens place and units place. Much the same way you will have 6 numbers starting with 4, much the same way, and 6 numbers starting with 6 and 6 numbers starting with 8. So if you see, there will be 6 numbers which are in the thousands place. We will be having 2. There will also be 6 numbers which will have 4 in the thousands place. There will be 6 sixes which are in the thousands place. There are 6 numbers with 8 in the thousands place. So this would be this way. Then there will also be similarly 6 numbers which will have 2 in the hundreds place, 4 in the hundreds place, 6 in the hundreds place and 8 in the hundreds place, right? And there will be 6 numbers which will have 2 in the tens place, 4 in the tens place, 6 in the tens place and 8 in the tens place. If you see for yourself, there will be 2 of the 4 numbers here, 2 of the 4 numbers in this place, much the same way. And there will be 6 numbers which will have 2 in the units place, 4 in the units place, 6 in the units place and 8 in the units place. Hence the total number of such numbers, basically it is 6 numbers, 6 into 2000 plus 6 into 4000 plus 6 into 6000 plus 6 into 8000 plus 6 into 200 plus 6. So we have simplified this whole thing. This turns out to be 6 into 20, 2 plus 4, 6 plus 6, 20 into whatever it is, 1111. 6 into 20 into 1111. Let's see what it works out to be. 620 into 1111, which turns out to be 1,33,320. That is, this one is the answer. So I hope you understood the logic. We just need to prepare a pattern. Here the question is not about how many such numbers are found. We are concerned about what is the sum of all such numbers. If you look at the pattern in the first 6, you'll be able to understand the patterns in the remaining. So if you see, there is 6 numbers having 2 in the thousands place, 4, 6, 8. Similarly for hundreds, tens and thousands and units place. And hence the total turns out to be 1,33,320. And yes, we do have that. Next in line. So the next in rank is, what is the rank or order of the word zenith in the dictionary? Now, an inbuilt assumption is, we are not talking about a regular dictionary. Maybe there is a dictionary. What they mean is that a dictionary containing only those words which have Z-E-N-I-T-H. Of course, they follow the usual rules of dictionary, that their words are arranged in alphabetical order. So we are considering those words, all the 6-letter words which contain Z-E-N-I-T-H. Those words may make sense, may not make sense, but all such words are included. So if we just look at the order, we could possibly, it would be E. The first word would be E-I. No, E-H, sorry, E-H-I-N-T-Z. So in alphabetical order, the first word is going to be E-H-I-N-T-Z. So this is word number 1. And the last word would be Z-T-N-I-H-E. This could be the last word. So how many such words do we have here? So there are 6, 1, 2, 3, 4, 5, 6. Since the letters are not repeated, so they can be arranged in 6p6 ways. That is 6 factorial ways. That is 720 such words. So this is the last word, 720th word. Now zenith is going to lie somewhere in between. Now we need to find out what the position in terms of rank, what should be the position of zenith. Now we will look at it this way. We have to take into account the alphabetical order. So we'll start with numbers which don't have Z in first place, or plus the ones which have Z in first place. Okay. Now this is easier to find, that they don't have Z in first place, so either they would be having E-N-I-T-H. So E-N-I-T-H can occupy the first place in 5 ways, and the remaining letters other than the one we have chosen can be arranging themselves in 5p5 ways. So there are 5 into 5p5, that is 5 into 5 factorial such ways, which will turn out to be 5 factorial is 120, so 5 into 120, that is 600 such letters which don't begin with Z. Now coming to this lot having Z in the first place. So we will consider those words which have Z in the first place and E in the second place. So now the Z and E can occupy themselves in one way and only one way. Then after that, we won't consider the one which has got N in the third place. We'll consider the ones which have I or H in the first place. Now so that means the third place will be chosen in 2p1 ways. So in 2p1 ways, I or H could be chosen. Then after that, so now 1, 2, 3 places are chosen already. So we have letters. So we are starting with words like Z-E-I and so on, or Z-E-H so on. Then after that, now since 3 letters are chosen, that is Z, E and either I or H are chosen, then the remaining 3 can be arranged in 3p3 ways. That is 3 factorial ways. The remaining 3 can be arranged. So this is the third lot. Then you will have also words starting with I and H have been done. We could consider those letters which would have starting with Z, E, N. Then we'll consider. So Z can be arranged in one way, then E, then we have N. Then after that, the next letter that we are going to choose we will not take I, zenith. Zen we will consider. So now Z, E, N are over, so we are left with I, T or H. So let us consider H over here. So if you consider H over here, there is only one way you can put, and I and T, the last two positions can be arranged in 2 factorial ways. So this turns out to be plus 1 into 1, 2p1 is 2 into 3p3, that is 3 factorial, 2 into 3 factorial is 12. And here you have 1 into 1 into 1 into 2, that will again be 2, that is 12 plus 2. Then, so now we have considered ZENH, and then we could consider ZEN and then I. We have ZENI and H has to follow and T has to follow. So there will be ZENIHT. There is only one way in this. This can be done 1 into 1 into 1 into 1 into 1 into 1. So we have ZENIHT. This word also occurs before zenith. And finally, you have zenith itself. Now, if the question was how many words occur before zenith, we won't consider this one. But the question is, what is the rank of zenith? So you have to include this. So once again, we will categorize them into 2 sets of words. One set of words are the one which do not begin with Z. So they don't start with Z. So they could start with E, N, I, T or H in 5 ways. And the remaining letters are arranged in 5 factorial ways. Then we consider those words which begin with Z and have E in the second place. So it's going to be ZEIH. So we are arranging in alphabetical order. The ones which begin with Z, E, I or H. So we have Z, E, I, H. So I and H can be chosen in 2 P1 ways. And then the remaining 3 are arranged in 3 P3 ways. Then we consider those letters, those words which have Z, E, N and H. In these places you have 1 into 1 into 1 into 1. And the remaining I and T can be arranged in 2 factorial ways. Then you have Z, E, N, I and H. And then you have T. So you have zenith. And the last one is zenith itself. This works out to be 600 plus 12 plus 2 plus 1 plus 1, which turns out to be 616. So the rank of zenith is going to be 616 among these. So among these you have 616th rank is zenith. Now candidates, one very important thing which often you could possibly face, since there is so much amount of brainstorming happening in this kind of questions. There are also words which could begin with Z with the second letter as H or the second letter as N. They will also exist in this dictionary, but they will follow zenith. They will follow zenith. So see to it that all those words ZH so and so, ZN so and so, ZT so and so, ZI so and so and all also feature in this particular dictionary, but they will follow. That means they will occupy all the ranks from 617 to 720. We are only concerned about the numbers which include the words which include zenith from the first one. So don't get confused over here. So hence there are 615 words before zenith, and including zenith there are 616 words. So the rank of zenith is 616. Mind you, again, if the question is how many words exist before zenith in this dictionary, it's going to be just 615. Okay, so this is one interesting kind of a problem which we are dealing with. So the answer, of course, is 616. Now, here we have an interesting situation. We have 3 ladies and 3 gents can be seated at a round table so that any 2 and only 2 of the ladies sit together. The number of ways is so. Now we have to understand any 2. It means that suppose there are 3 ladies. Out of those 3 ladies, 2 of them, any 2 could always be together, but the third one will not be with them. Definitely not be with them. So we could possibly just understand that suppose there are ladies, 2 ladies, and then there are gents, and there is another lady too. Okay. So now, it's like telling 1, 2, 3, 4, 5. You have n terms in a circular arrangement. We have n in a circular arrangement. Out of that, these two ladies and this one are never together. So it's like telling this unit and this unit. Two of these units can never be together. These two are always together. These two means any two of them would be do. Maybe this one could be going there. So these two. So in this case, it is a case of m being equal to 2 and n is actually 5. Now m of them are never together. So we use, in such a cases when they are never together, we use the formula n minus m minus 1 factorial. How many ways they can be arranged? N minus m minus 1 factorial into n minus m pm. So n minus m minus 1 factorial is 5 minus 2 minus 1. 5 minus 3, 2 factorial into n minus m pm. 5 minus 2, 3 p2. Now this is just the arrangement of these people. But it is also told that L1, lady 1, lady 2 and lady 3 themselves can form groups of L1 and L3, L2 and L3, L1 and L2, and within this there is arrangement L1 on the left, L2 on the right, or vice versa. So that means these three ladies themselves can be grouped into small groups of 2 in 3p2 ways. So first we make the arrangement of the gents and ladies around a circular way in such a way that one lady who's single and the two who are together are never together. So we can take them as two individual units, that is n minus m minus 1. So it is 2 factorial into 3p2. Then the three ladies who are put in two groups of 2 will be chosen in 3p2 ways. So we have 3p2 into 3. So that is going to be 2 factorial, which is 2 into 3 factorial upon 3 minus 2, 1 factorial into again 3 factorial upon 1 factorial, that is 6 into 6, 36 into 2, 72 possible arrangements we have of these ladies. So we have 72 arrangements of these ladies this way. So we have 72 ways in which these ladies can be arranged, and that's what we have over here. So this is a very interesting example of sitting around a table and two of them not being around. Okay. Now we have the next one, which says the number of parallelograms that can be formed from a set of 4 parallel lines. So we have 4 parallel lines, 2, 3 and 4, intersecting another set of 3 parallel lines. So this and this. We need to form parallelograms. How many such parallelograms? So there could be a parallelogram this way, or this way, or this way, or this way, or this. That means each parallelogram will have 2 pairs of opposite lines. So that means there are, we need to pick up parallelograms. How we need to, the order is not important, A, B, C, D or this way, it's all the same. So this is, understand that this is, the previous one was a question of arrangement, so it involved permutation. Here it is just selecting. Say suppose it is, you're selecting line AB and line CD and calling it quadrilateral ABCD, or CD and AB and call it CDBA, it's all the same. So it's a clear-cut case of combination. So how do we select? We select, for each parallelogram, we select out of this 1, 2, 3, 4. 4 we select 2. And for the opposite sides, we need 2 more parallel lines out of these 3. We select them in 3C2 ways. So it's 4C2 into 3C2 ways that we do it. So this is 4 factorial upon 2 factorial and 2 factorial. And this is 3 factorial upon 1 factorial and 2 factorial. This is going to be 4 factorial is 24 by 4, 6 into 3 into 2 factorial by 2 factorial. So that will be 18 such parallelograms can be made because of this. So we have 18 such parallelograms by choosing 1, 2, 3, 4. 2 out of these 4 parallel lines, 1 pair of opposite sides, and the other pair of opposite sides are being chosen out of these 3. So that is 3C2. Mind you, it's not a permutation because the order in which you choose is not important. So there are 18 such parallelograms and hence we have 18 of them. So here we have a number of ways in which 12 students can be equally divided. So there are various ways of doing. So first, out of the 12, you would possibly choose 4. And you have 12C4. And then now these 4 need not be alike. Then now how you choose them is not important. Which order you choose them, you must choose A, B, C, D or B, C, D, A. So hence it's a combination. Now out of the 12 you already chosen 4. Then there are 8 left. So it will be 8C4. 4 more have to be chosen. And then finally there are just 4 left. So you choose them in 4C4 ways. That's only one way. Now 12C4 is going to be 12 factorial upon 8 factorial into 4 factorial. This will be 8 factorial upon 4 factorial into 4 factorial into 1. This will turn out to be 12 into 11 into 10 into 9 into 8 factorial upon 8 factorial into 4 into 3 into 2. This gets cancelled, of course. 4 3s are 12. 2 5s are into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial into 4 into 3 into 2. This of course gets cancelled and you have 4 into 2. So you have 55. So we have 9 5s are 55. We have 55 into 9 into 14 into 5. Is 4. It turns out to be 495 into so that turns out to be 495 into 70, which turns out to be 34,650. And now that's not possible, so it has to be none among these. So 34,650 is the answer, which doesn't tally with anyone among these. And we have 34,650 as the answer. Yes, that's what we have. It's none among these. Okay. Now, the number of ways in which 9 things can be divided into 3 groups containing 2, 3 and 4 things respectively is what? Number of ways, we follow the same principle. 9 things can be divided into 3 groups containing 2. So, the first 2 will be selected out of 9. Then the next 3 would be selected. 2 have gone away. So, it's going to be 7C3. Now, out of 9, 5 have gone. We are left with only 4. So, it's going to be 4C4. So, the first 2 are selected out of 9. Now, since the 2 are selected, 2 more are left. 2 more less are available to select 3. So, 7C3. Now 2 and 3, 5 haven't removed. The balance is 4C4. So this is going to turn out to be 9 factorial, 2 factorial, 7 factorial into 7 factorial upon 3 factorial into 4 factorial into 1. This would be 9 into 8 into 7 factorial upon 2 factorial into 7 factorial. This will be 7 into 6 into 5 into 4 factorial. On 3 factorial into 4 factorial into 1, this gets cancelled. This is 9 into 72 by 236 into 35. 36 into 35 we have here 36. So it turns out to be 1260. 36 into 35, which turns out to be 1260. So there are 1260 ways in which they can be put into groups. So our correct answer is 1260. And we do have that as the answer, 1260. Now what do we have next? Okay. The number of ways in which 15 mangoes can be equally divided among 3 students is, so the 15 mangoes can be into 3 students, so they can be divided, 15 is divided by 3 into groups of 5 mangoes, so it is a kind of a permutation. So we are using the formula n factorial upon p factorial, q factorial into r factorial. So this is going to be 15 factorial. First group has 5 factorial, then second group, then third group has 5. So there are 5 mangoes which are arranged, selected this way, 5 mangoes selected in this way. So now we can arrange them hence in 15 factorial upon 5 factorial cubed base. So which is going to be the same. Or we can even do 15C5, then you can reduce 5, 10C5, and the last would be 5C5. All of these work out to be the same. We can use the same principle which you did in the previous question, or you do it this, it will all work out to be the same. So we have the right answer that way. Then the next question turns out to be that number of different words that can be formed with 12 consonants and 5 vowels by taking 4 consonants and 3 vowels in each word is what? So now here we have the number of different words that can be formed. So this is it is an interesting example wherein you need to form words. So first is step 1 is selection. And step 2 is arrangement, which means selection is a combination and then we need to arrange them, so it's a permutation. So let's see how to select first. So 12 consonants and 5 vowels by taking 4 consonants. So you're going to select them in 12C4 ways into 5 vowels. Out of the 5, you need to select 3. So after selecting, you will get 4 plus 3, 7, which have to be arranged within themselves without repetition in 7 factorial ways. So first you select 4 out of 12 consonants in 12C4 ways, then 3 out of 5 consonants in 5C3 ways, and whatever has been selected has to be arranged in 4 plus 3, 7 factorial. Now this turns out to be 12 factorial upon 8 factorial into 4 factorial into 5 factorial upon 3 factorial into 2 factorial into 7 factorial. This would be 12 into 11 into 10 into 9 into 8 factorial upon 8 factorial upon 4 into 3 into 2. So this gets cancelled. Of course, here it is going to be 5 into 4 into 3 factorial upon 3 factorial into 2 factorial. This gets cancelled. This becomes 10. This will be 12, 5. So it's going to be 4 into 7 factorial, of course. 495 into 10, 4950 into 7 factorial. So 4950 into 7 factorial ways in which this selection can be done. So the correct answer is 4950 into 7 factorial. And that's what we get over here.